Hello and welcome back. We are going to proceed from where we left during the last video, and that is question number 11. So straight away let's get to question number 11. So question number 11 states that given that B is equal to a column vector 2, 4, C is equal to 3, 2, and A is equal to 3C minus 2B, find the magnitude of A correct to 2 decimal places. Okay, so we're given that B, vector B, okay, so I'm going to make B bold just to indicate that it's a vector. So B is equal to 2, 4. Then we have C is equal to 3, 2, and A is equal to 3C minus 2B. So we are required to find the magnitude of A correct to 2 decimal places, but as you can see, A is written in terms of B and C. So we need to evaluate the exact value of A. So what we are going to do is we're going to have A is equal to 3 times C. So 3 multiplied by vector C, which is 3, 2, and then minus 2 multiplied by vector B, which is 2, 4. Okay, so sometime back in the past we learned how to multiply a vector by a scalar. So if you haven't checked out that video, I'm going to leave a link to it in the description box so that you get a chance to learn more about how to multiply a scalar by a vector. So what we are going to do is that A is going to be, so we multiply this scalar by each of values of this vector, that is x and y. So it's going to be 3 times 3, which is 9, and then 3 times 2, which is 6. Okay, and then minus 2 times 2 is going to be 4, and then 2 times 4 is going to be 8. So we can now work out this. So we're going to subtract 9 minus 4 is 5, and then 6 minus 8 is negative 2. So that is the value of A. So we can now proceed to find the magnitude of A. So how do we find the magnitude of this vector? So assume we have a Cartesian plane. So let me try to map this vector on a small Cartesian plane, just a sketch. So this is our x-axis, and this is our x-axis, and this is our y-axis. So we have point 5, let's say 5 is somewhere there, and negative 2 is somewhere there. So we have negative 2. So if we assume that the origin of this vector is 0, 0, okay, that is the origin. So we can have something like this, okay, and we can say that this is vector A. So the magnitude of this vector means, or when we are talking about the magnitude, we mean getting the length or the size of this vector from the origin up to this point. So how do we go about it? So if I draw a dotted line at this point, that way, so you can see we have a right angled triangle, and this right angled triangle measures x units, that is from here to here, we have x units, or it's along the x-axis, and we are going up to 0.5. So along this length, we have 5 units along the x-axis, and downwards we have 2 units along the y-axis. So what does this mean? So we can use the Pythagoras theorem to get the length of this vector, which for this case acts as the hypotenuse of this small triangle. So to get the magnitude of A, which you're going to represent that way, okay, so the magnitude of A is equal to the square root of x squared plus y squared. So for this case, we have x as 5 units, so it's 5 squared, plus y, it's 2 squared. So this is equal to, so 5 squared is 25, and 4 squared is 4, so we have 25 plus 4, and this is equal to the root of 29. So the root of 29 is, so you can use your calculators. The root of 29 is equal to 5.385. But remember, we were supposed to give our answer correct to 2 decimal places. So it's going to be, when you round off, it's going to be 5.39, okay, units. So that is the magnitude of vector A. So I believe you have understood that question, and we can now proceed to the next question. So question number 12 is a construction question. So what I'm going to do is that I'm going to skip that question for now. I'm going to create a separate video for question number 12 only, because it's going to require a significant amount of time. So for now, allow me to proceed to question number 13, and then for question number 12, you will check out the next video. I will create an entire video for only question number 12, so that you can get to understand in a better way without a limit of time. So let's move on to question number 13. So question number 13 states that solve the inequality 2x minus 1 is less than or equal to 3x plus 4, which is also less than 7 minus x. So let me write it down here. So we have 2x minus 1 is less than or equal to, let me write the inequality sign in a different color, is less than or equal to 3x plus 4, which is also less than 7 minus x. So we are required to solve that inequality, or rather to find the values of x. So I remember some time back in the past, we learned how to solve inequalities. But if you did not get a chance to watch that video, I'm still going to leave a link to it in the description box, so that if you did not get a chance to watch it, you can get to learn about linear inequalities. So what we're going to do is that we're going to extract 2 linear equations from this compound equation. So this is going to be one of them, and the other is going to be this one. Okay, so I can write them down here. So it's 2x minus 1 is less than or equal to 3x plus 4, and the other one is 3x plus 4 is less than 7 minus x. So we are going to solve for each one of them separately. So let's start with this one. So as I said during the video that I talked about where we were learning how to solve linear inequalities, I said that we treat the inequality symbol as an equal sign, okay? And then proceed to solve this inequality as if there were an equal sign here, okay? So what we are going to do for this case, we can subtract 2x on both sides, okay, so that we have -1 is less than or equal to x plus 4, okay, and then we can subtract 4 on both sides so that we have x, okay, so if it's this way, it's x is greater than -5, okay. So we can now solve the other inequality. We can add x to both sides, so plus x, so it's going to be 4x plus 4 is less than 7, okay. And then we can subtract 4 on both sides, so -4 minus 4 to put like terms together, so it's going to be 4x is less than 3. So to get the value of x, we divide through by 4, and x is going to be less than 3/4. So we have two values of x, or rather two inequalities. So this one is the same as, so that we don't get confused, we can write it as x is greater than or equal to -5. So we have solved for the inequality. We can also represent these inequalities on a number line, though we were not required to do so by the question, but just for the sake of reminding yourselves what we learned during that video, probably you can pause the video and try to represent these two inequalities on a number line. So how do you go about it? So first is to draw a number line, okay, that way. So this number line is going to run from -5 to 1 probably. So we can have -5, -4, -3, -2, -1, 0, and 1. So remember, this is just a sketch, it's not drawn to scale. Then what we do, as we said during that video, we are going to circle the 2 points of our inequalities, so that is -5 and 3/4. So 3/4 is somewhere here. But then remember, we said that if one of them has an equal to sign, that is, for example, for this case, it's x is greater than or equal to, we make that circle closed, or rather we shade that circle to represent a closed circle. In other words, it means that -5, it is part of that inequality. So x is greater than or equal to -5. So -5 is part of that inequality. But for this case, x is less than 3/4 or 0.75. So that means 0.75 is not part of that inequalities. So all these other members of values from -5 coming all this way up to this point, but remember 0.75 is not part of the inequality, fit into this inequality. So that is how to represent this inequality on a number line. So I believe you can recall that. So as I said, I'm going to leave a link in the description box that is going to direct you to that video where we learned about linear inequalities. So we can now proceed to question number 14. So question number 14 states that given that matrix A is equal to 2, 3, 4, 4 and matrix B is equal to x, 1, 2, 3 and that matrix A times matrix B is a singular matrix, find the value of x. So we are given that matrix A is 2, 3, 4, 4 and then matrix B is equal to x. So we are not given the value of that figure that is represented by x, and then 1, 2, 3. And then we are also told that matrix A multiplied by matrix B should give us a singular matrix. So what is a singular matrix? So a singular matrix is a matrix whose determinant is 0. Okay? So if we multiply matrix A by matrix B, we should get a singular matrix, or rather a matrix whose determinant is 0. So let's first multiply matrix A by matrix B so that we can get the value of matrix A times B in terms of x. So you can see we have an x here, and then we can now equate it to 0 because we are told that it's a singular matrix. So sometime back in the past we learned how to multiply matrices, but if you never got that opportunity, I'm going to still leave a link in the description box that is going to direct you to that video. So how do we multiply matrices? So as we said during that video, we multiply a row, okay, a row by a column. So for this case, we are going to multiply, okay, so let me have that. So the value of this first figure here, that is the element of the first row and the first column, is going to be 2 times x, and then plus, so that is 2 times x, and then 3 times 2. So it's plus 3 times 2. So that is the element, the product of the first row and the first column. So what about this element here? It's going to be the first row by the second column. So it's going to be 2 times 1 plus 3 times 3. So 3 times 3. Okay, what about this element here? It's going to be the product of the second row by the first column. So it's 4 times x, so 4 times x, and then plus 4 by 2. 4 by 2. What about this last element? It's going to be the product of the second row and the second column. So it's going to be 4 times 1 plus 4 times 3. Okay, 4 times 3. So we can now simplify this. So 2 times x is 2x. Okay, so it's going to be, so it's 2x plus 3 times 2 is 6. So it's 2x plus 6. Okay, and then we can now move on to this one. It's going to be 2 times 1 is 2. So it's 2 plus 3 times 3 is 9. So it's 2 plus 9, it's 11. So 4 times x is 4x. And then 4 times 2 is 8. So this is 4x plus 8. And then finally we have 4 times 1 is 4 plus 4 times 3 is 12. So it's 12 plus, sorry, 4 times 1 is 4. and then 4 times 3 is 12. So it's 12 plus 4 is 16. I'm sorry for that. Okay. So now we have a singular matrix. Okay, we are told that the product of A and B is a singular matrix. And as we have said, a singular matrix is one whose determinant is 0. So the determinant of this matrix is equal to 0. So how do we find the determinant of this matrix? Again, we did this some time back in the past. So the determinant of a matrix, of a 2 by 2 matrix, is found by getting the product of this row and then subtracting the product of this diagonal. Sorry, not row. So let's work out that. So let's get the product of this diagonal. It's 16 multiplied by 2x plus 6. Okay, and then we subtract 11 times 4x plus 8. Are we together up to that point? Good. So this is going to be 16 times 2x is going to be 32x, and then plus 16 times 6 is 96, I believe so. Yeah. And then minus 11 times 4x is 44x. And then plus, sorry, not plus, but minus. So, sorry. It should be minus. Minus 88. So this is minus 88. So we can now equate it to 0. Okay, so when we put like terms together, so 32 and negative 44x, that should be negative 12x, is equal to, so 96 minus 88 is 8. Okay, sorry, it's minus 8. So before, okay, on this side it was positive 8. So when we subtract 8 on both sides, so it should be negative 8. So we can now divide through by negative 12, so that the value of x is 8 out of 12, which can be simplified further to, okay, by 4 it's 2, and by 4 it's 3. So that is the value of x. So if you find this video helpful, please consider subscribing and also turning on the notification bell so that you don't miss out on any video that I upload. So goodbye for now, and let's meet in the next video.